Wait ko lang yung confirmation ni Google, no? And then that's it. So we go now to the operations on sets. The operations on sets. Operations on sets behave in a manner somewhat similar to the basic operations on numbers. Like in our fundamental operations now, addition, subtraction, division, and multiplication are operations on numbers. We also have operations on sets. Okay, now let's define first the Venn diagram. The Venn diagram of sets makes use of a rectangular representing the universal set, and the circles are subsets which be shaded under consideration, depending on if which operation are we trying to illustrate. So I'll be illustrating each operation using the Venn diagram. Let's start with there were four basic operation on sets. Let's start with the union of two sets. Let me just prepare my Venn diagram. Here, I need more space, no? Wait lang. All right. So Venn diagram, we have here your universal set. When we say universal set, this means that all the elements under the consideration belongs or are within this rectangular plane. Okay. And then we have subsets. Let's say set A, set A, and then let's have another set here, set B. Okay, set B. Okay, let's have our title. This is again the universal set. And then let's say we have set A and set B. Okay. Duplicate ko lang yung copy na. Ayan. So, first operation, we have the union of A and B. Union of A and B. Union is denoted by the symbol U. Okay? Union of A and B. Now, based from our definition, the union of two sets is a set of all elements found in both A and B, or both sets. Specifically, in our case, both A and B. So all the elements found in A and in B, no? Now, if we were to shade that portion, then we'll be shading set A, all members of set A, and all members of set B. Okay. And their overlapping part as well, no? Both that can be found both in A or in B. Okay, so this is your union of sets. The union of sets. Okay, the second one, we have the intersection denoted by the inverted U. Inverted U. This is a set of all common elements of the two sets. Common elements. This can be found in the overlapping part between the two sets. The overlapping part between the two sets. So let's say We have A at the intersection of A with B. Okay, so we'll be shading the overlapping part of A and B. Okay. Here we can identify the common elements of A and B, the common elements, the overlapping part. All right. Next operation, we have the complement of a set. Complement of a set, denoted by the apostrophe, or this is being read as prime or complement, complement of A or A prime or whatever. It is a set of all elements in the universal set not found in the given set. Okay, set of all elements in the universal set not found in A. Let's say, for example, if you wish to determine the complement of A, denoted by this symbol, a complement of A or A prime, you can read this as complement of A or A prime. So based from our definition now, all the set of elements not found in A under the universal set, no? Under the universal set, hindi lang yung wala kay A, ay na kay B, but under the universal set. Ayan, this is your A prime. Okay, this is your A prime. All right. Next and last operation, we have the difference of the given set. Difference, where is it? Ayan. Denoted by symbol of difference, of course, the minus sign. It is a set of all elements found in one set but not in the other set. Found in one set but not in the other set. Alright, so how can we illustrate that in the Venn diagram? Let's say we wanted to determine the difference between A and B, or that is A minus B. A minus B. So this is all the elements of A, but not in B. Okay, these are the unique elements of A. The unique elements of A. So we'll be shading just this part. Okay, well, we get rid of their intersection. So you only consider the unique elements of A. All right. Now, if we, on the other hand, if we wish to determine the difference between B and A, B minus A naman, and then we'll consider the set of all elements in B but not in A. I set of all elements in B but not in A. So we'll be shading just this part. Okay? Any question? We have here the application of operations on set. Given the universal set and set A, B, and C here, the definition, there are already solutions here naman. And you may refer from the illustrations I provided you a while ago, yung shading of the Venn diagram natin. Or in fact, no, in fact, you may be able to identify the solutions to these problems even without drawing the Venn diagram. Okay? Kahit na wala kayong Venn diagram, masasagot nyo to. For example, the union of A and C, all you have to do is to identify to write all the elements of A and C. Okay? All the elements of A and C. And that would be their union. Okay? Intersection naman, identify the common elements of B, common elements of B and C. Okay? Common elements of B and C. And that would be their intersection. And letter A, number 3, you may or may not apply the distributive property since we found that left and the right side of the equation were the same lang, no? So you may just simplify the parentheses and then later on, kunin nyo yung union niya with A or pwede nyo rin naman gamitin yung distributive property. Nonetheless, you'll be arriving at the same solution pa din naman. Okay? And then if we have same operations, then regardless of the grouping, or you may just write them without grouping. This means to say you are looking for the intersection of the three sets. Saan sila? Ano yung common element among the three? Okay? Among the three sets. And then B minus C, again, define natin. This is the unique elements of B na wala kay C. Okay, unique elements ni B na wala kay C. So we have here 1, 12, and 15. Kasama si 5. 1, 5, 12, and 15. All the elements of B not in C. Then we have the intersection, the complement, all the elements not found in A. So andyan si 1, 2, we have 4, we have 6, 7, 8, we have 13, and 15. So, ito yung A kasi natin eh. Ito yung A natin. 1, 2, 4, 6, 7, 8, 13, and 15. So, yung naiwan, we have 3, 5, 9, 10, 11, 12, 14. This is the complement of A.